Hey everyone, welcome to the Exhibitor track. I'm Hitesh Bambani, a volunteer on the OWASP community. I'll be moderating this session. During the next 45 minutes, you'll be listening to Eylam and more. They're presenting benchmarking the security of your software supply chain. Please submit any questions you have during the session in the Q&A tab that's just to the right of this video in the OWASP platform. I'll be asking them your questions in the last 10 minutes of the session. Also note that the chat function in Zoom is disabled for attendees, but you can still leave comments in chat in the OWASP platform. Okay, so let's talk about the speakers. Eylam is co-founder and CTO of Argon Security, which is now part of Aqua Company. Argon enables DevOps and security teams to protect their software delivery pipelines against supply chain attacks. You see a lot of those misconfigurations and vulnerabilities. Before founding Argon, Eylam served as a security team lead in the Israeli military for 7 years as the founder and consultant of various startups. Joining him is Moore, who is a senior software engineer at Argon. Moore has vast experiences analyzing threats targeting cloud-native environments and developing solutions against those threats. He loves swimming and traveling with his wonderful wife and kids. So, gentlemen, please go ahead and share your slide deck.
Okay, great. Thanks for the introduction. Amazing. So as Hitesh said, we'll be speaking about benchmarking your software supply chain. Just a very quick introduction of us. So my name is Eylam. I'm the CTO and co-founder of Argon. As part of my day-to-day job, I get to speak with a lot of DevOps and security teams, really on amazing topics. So hopefully I can share some of those insights today with you and more.
Hi everyone, I'm More Weinberger, father of 2 awesome kids, and I've joined Argon as a senior software engineer 7 months ago. Prior Argon, I worked for Microsoft for 4.5 years around cloud security threats products and have quite experience in cloud native threats. And actually, I'm really excited to be here.
Great. So just a quick word about Argon. So Argon was a company that founded on the basis of helping other companies secure in the software supply chain. We have recently became part of Aqua Security, which does a lot of awesome work around security as well. And together the mission is really to help all companies to stop cloud native attacks. Our focus today is specifically the software supply chain, so that's what we'll cover. Just to give you a heads up on the agenda. So we don't have a lot of time, but these are the things that we'll cover. The intro of us is done. Next, I'll give us just a brief overview of the software supply chain. So I know this is a technical crowd here, but still I think there's a lot of confusion around the topic. So I'll give us like a 0 to hero kind of an overview. Then we'll talk about some attacks, which is the more interesting part. We'll dive deep into some of them. And finally, Mo is going to share with us a live demo of a project that will be revealed here for the first time. So this should be exciting, and that's it for today. So about the software supply chain. I know this is a term that is already thrown out there a lot, but I do see a lot of confusion about what is the definition of it. So we try to kind of clearly define it here. So anything that is in your source code or affects it in any way from the moment of development throughout the build pipeline, the packaging, and up until the time it is ready to be deployed to production. So commit to deploy, as we see here from left to right, this is the time frame that we often refer to as the software supply chain. And we can see here it's composed of essentially 5 different layers. So the first one would be the source code, where you work with your team on the code base, contributing to it. The second part is the dependencies of the code, known as material as well. Anything you bring into to be part of your development process. The build, where CI pipelines take your source code, compile it into something that is runnable, so an artifact. This is the 4th phase, so managing those artifacts, those different versions of your microservices. and right up until the time you're ready to deploy them to whichever environment you want. So your development environment, your production environment. So these are kind of the different layers of the software supply chain, and this is the time frame where it exists. And the thing about it is that today we can see kind of a simple example of a software supply chain process. And I guess even the more simplest examples are still kind of very hectic and very complex. And it didn't really used to look like that. So in the past few years, in a relatively short time span, we saw a dramatic shift in technology, in the way this process is composed. So companies don't release software today as they used to just 2, 3, 5 years ago. So a very short time span for a very rapid change in the process. So just to kind of demonstrate how rapid this change was, I tried to touch here on some interesting points on the timeline. So we can see here that GitLab, the DevOps giant, one of the big four, which we all know today, just in 2015, not so long ago, was a 10-people operation, which is insane to think about. Right after that, Google Cloud got into the building software aspect with only a beta release of its build service. After that, in 2017, Bitbucket Pipeline was introduced to replace the older Bamboo, and Azure DevOps Cloud, which is now one of the more popular platforms for software companies out there, is only officially launched under the name Azure DevOps in 2018. And GitHub, of course, one of the bigger players in the market, has actually only introduced its CI platform in 2019 when it became GA. And this is insane to think about because today it's the third most popular CI platform out there. And it only exists a couple of years. Container registry was also introduced last year. So you see kind of how things we take for granted today while we develop, and I'm referring to the community of engineering, of developers, of DevOps, are not so veteran in the market. They are relatively fresh, and the processes that were created around them are definitely fresh as well. And this is why it's a challenge to make sense of it and definitely to secure it. So just kind of like a general overview of how security personnel see this market. So I will not go over the numbers here, and you shouldn't either. I'll give you the highlight. So we conducted a survey around the software supply chain security topic. We questioned over 200 CISOs globally, so all over the world. And we asked them, well, question about how they feel about security of the software supply chain, which endeavors do they take on securing it. And I won't touch on all the points, but just like two major factors that I took as very interesting was one, the majority of companies actually use over 3 different platforms, DevOps platforms, to build their software. And every platform is like a small universe on its own. So going across at least 3 of them is definitely part of what makes this process so hard to manage. The second point, which I find to be the most interesting, is we ask them one question, those security personnel, those security experts. We ask them, what is the #1 difficulty in securing your software supply chain today? And the #1 result that we got was collaboration between DevOps and security teams. And it's an incredible thing to think about because the #1 challenge is not about code, not about technology, not about any other tool out there. It's about people, it's about processes. So I think this kind of well reflects like the issue of software release. Okay, so now hopefully that we got a little clearer about the software supply chain and its different aspects. So let's talk about recent events, including attacking the software supply chain. Amazing. So we see here some 4 of the bigger, more known events. These are kind of events that pave the way into public knowledge of how important it is to secure your software supply chain. So I won't deep dive into the 4 of them. I'll just give us a quick overview and then we'll dive later on. So the #1 on the left on the top left, we see is the case of Mercedes-Benz, where roughly 600 code repositories, private code repositories, were leaked online through their GitLab server, their private instance, on-premise instance of GitLab server, due to failure in configuration of the set of tools used there. So a hacker was able to leak them out online. The one just below it is the case known as CI poisoning of a company named Codecov, that an attacker was able to gain access directly into the CI environments of software companies, so where they build their software. This is a more sensitive area, and we'll talk about this one specifically in depth right after this. The one on the right, dependency confusion, is one of the more familiar topics. It has its own buzzword, so dependency confusion. The idea is that attackers were able to demonstrate just how easy it is to confuse your package manager, your registry services, into pulling external packages, external code packages into your private environment instead of the one that you meant to pull that are private to you, essentially running someone else's code on your private premise very easily. And I think like the fourth one doesn't really need any introduction. So SolarWind, in a sentence, a build time code injection, where attackers gained access to the build environment of the Orion app, were able to inject code into the app, affecting tens of thousands of customers worldwide. And maybe some more recent attack, more?
Yeah, so regarding more recent trends, we all heard about Log4j vulnerability that affects basically every organization that depends on software which are written in Java. But we also started seeing in the last year that even the maintainers of popular open source project that we all use put us, the consumer, at risk. So here are just a few examples. Color.js and Faker.js are quite popular packages with more than 21 million weekly downloads. And suddenly the maintainers add a malicious code that runs in an infinity loop, which basically breaks the system that runs it. Later on, he published a message that described the reason behind it. He basically was upset that the commercial product extensively rely on his contribution without give back, or how he said in his own words, he provided free work. Node.apc is another example of what is now called protestware, which is a merge of two terms, protest and software, where the maintainers adds code that checks if the machine that use it came from a Russian or a Belarusian IP address. And if so, it basically wiped the hard disk. And as you guessed, this was a political protest of the maintainer that aimed to support the Ukraine efforts in the ongoing war. So we are really seeing here that the attacker personas and the intention are changing from what we used to in the past.
Great. So finally, let's dive into a few attacks. The idea is to better understand the concept of securing your supply chain with looking at some of the more sophisticated attacks. So this one is actually kind of nice because it's not one of the most heard of, but it's definitely a widespread one and an important one to understand because the concept of it is definitely something any DevOps team should be aware of. So this is the case of a GitHub action. Its name is check spelling action. And we can see here the security advisory message that actually started the whole topic. We can see it's about a leakage of a GitHub access token. So looking at those lines, what we see here is the way engineering teams use this action. So a GitHub action is a small piece of code, and the check spelling one, well, it check spells your code. To every pull request submitted to your code repository, the check spelling action would check it and verify that you don't have any spelling errors. And this is actually the concept of actions, right? So the idea is you take someone else's code, wrap it in an action, it's open source, and then you use it in your CI pipeline. And it's easy to install them just as it is easy to install applications from the marketplace. So we see here GitHub's marketplace for actions, where you can download and use the check spelling action. And the thing is that it's no longer just the application that has the dependency, right? If it used to be my node module folder, which contains my application dependency, now my CI pipeline itself also contains dependencies. So my pipeline dependency, and if you recall the definition of the software supply chain, so anything affecting my source code from the moment of commit up until the moment of deploy, well, those pipeline dependencies definitely do affect my source code. So let's see what happened there. So a check spelling action, as we said, and the problem was with its workflow. So workflow is GitHub's CI, and it's a YAML file with a set of instructions on what to do on my source code. Now we can see the screenshot from the documentation. Just copy the spellcheck.github directory into your project, and then you would enjoy the workflow. Unfortunately, this workflow was very improperly configured. So it opened up any code repository into the attack. Essentially, it allowed attackers to gain write access to the repository. So again, write access to your code repository means someone else that you didn't grant access can write code to your private project. So how exactly did this happen? So we can see here the impact definition of the event. So the repository check spelling action enabled the trigger. The trigger name was on pull request target. So some of you might be familiar with the name, some of you might not be. The pull request target event is the name of an event that GitHub lets you choose as the triggering event of your pipeline, of your workflow. Now it is annoyingly similar to the other trigger, pull request, without the target. But the idea is that the pull request target event is the trigger that was actually allowing the attacker to send a pull request against your repository and easily extract your GitHub access token, which has write access, as we'll see in a second, and with it, just make an easy API call to change your source code. So this is the example of the workflow. This is how it looks like. So we can see on the top of the screen, we can see the pull request target. This is the event. And the danger thing to do is to combine the pull request target event together with the checkout of the specific pull request. Now, the reason this is dangerous is because GitHub CI runners, those small utils that take your source code and build it, they let this pull request run in the context of your private environment because you're using the pull request target event and you're checking out the same pull request. Anything written in the workflow of this pull request would be run on your private environment. This means the context it will be used is with your own GitHub access token. Each one of those runners is issued a GitHub access token. And if I gain access to it, then I can do whatever I want with the source code. So some workarounds to that. So obviously a workaround would be to disable the workflow. I guess this is not really solving the problem, but rather ignoring it. And then we had this instruction to allow actions only created by GitHub. So this got me thinking, what's the default level of allowance that we have, right? Because if this is the recommendation, then what happens when I create a new repository from scratch? So that's what I did. I created a new project. And you can see here that the workflow, my project CI, actually has read and write permissions. This means, when you can see in the subtitle, the GitHub access token that allows my CI runners to do actions on my source code is by default granted read and write access. And you can obviously go here and check for yourself. But not only that, the actions themselves that I choose to install are also by allowance, are just kind of very including. So all of them. Anyone that releases an action to GitHub's marketplace, I can actually install it and run it as part of my CI, as opposed to only one verified by GitHub, for example, or only one verified by my organization. So the solution of that would actually be to just upgrade to the later version, which already did not include the misconfigured workflow. However, there's a catch. So the idea is that if you're an open source maintainer and you have a public repository with the check spelling action, then it's not enough to update the check spelling action on your main branch. You would have to go throughout all your branches, throughout all the history, and make sure that none of them contain a copy of the misconfigured workflow, because an attacker can open up a pull request against one of those branches and gain the same level of access to your repository. So a solution with a catch, not a fun situation to be in. Great, so anatomy of an attack number 2, and then we'll hand it over to you, Mo. So another action to continue the sequence, but on a whole other angle of attack, would be the instance of CodeCov. So we mentioned it briefly very earlier. We can see here the lines which I would use as a developer, as a DevOps engineer, to upload my test coverage to CodeCov's platform. So what happened there? So CodeCov is a very popular test coverage solution. You can see here how it looks like. You use it as part of your CI mostly. You can either use the GitHub action, wrapping it, or you can just directly download the CodeCov automation script. And it was hacked. It was hacked pretty bad. And essentially it affected all CI pipelines using it. So what exactly happened there? So an attacker was able to modify one of CodeCov's automation scripts, so changing the source code of it. The reason for it is unknown. It has yet to be publicly exposed, but it has come to our attention that it was due to gaining access to CodeCov's private Google Cloud storage with an access token. The access token was leaked through a build process of a container image. Now, this is a topic all on its own, but what I've learned from researching the topic is that it is an extremely easy thing to do, to leak sensitive data when you're building Docker containers. As an engineer, I was very surprised to learn how easy it was. You can see here, even the Docker history command might be revealing for you. So gaining the access token allowed the attacker to change the source code. This is how the code itself looked like. It's a small utility, nothing special. And this is the single line of code that was added by the attacker. So those of you who might be coders would definitely be able to figure out what it does. It's a very simple line. So it prints out the environment variable, which I currently have access to, and sends them out back home to a remote server. And since this is something running as part of my CI environment, then by definition, I have a lot of sensitive environment variables there. So essentially, I've exposed access tokens, user credentials, API keys, whatnot, right to the attacker's server. Now, the results of the hack were pretty massive. So you can see some companies here, large companies, who publicly acknowledge they were indeed affected by the hack. But not only private companies. So open source projects, a lot of them relied on CodeCov, some of them very popular. So we can see here Argo CD, Kubernetes, Ansible, Webpack. Those were all projects using CodeCov as part of their CI and potentially with the sensitive data leaked right out of it. In the time of the attack, if you would have gone to GitHub and searched for the lines, then you would see roughly around 400,000 results across code bases, across files, which just goes to show how popular the usage of it was. Okay, and now Mo would take us to anatomy of the third attack.
Amazing. Just a second, I will take the control. Okay, can you see my screen?
Yes.
Amazing. So Eylam just showed us an interesting technique attackers use to breach the software supply chain, but one might think that only sophisticated or nation-state attackers are able to perform software supply chain attacks. And this is really not the case here. In the last year, we saw an increase in cases of bad actors that has a great passion for crypto mining by abusing CI/CD compute power. So what they do, they basically focus on finding vulnerable platforms like in the case Eylam shows, or they basically look for the free tier of those platforms like GitHub Action or GitLab. So let's see how it actually looks like when your platform being abused. So here you can see a GitHub Action statistic history that shows an attacker that run multiple build steps in parallel within just a single plan. Each job here runs for 6 hours, which is the maximum runtime allowed. And a closer look at the pipeline declaration revealed the actual instructions behind it. So what we could see here, a few optimization settings like limit the parallelism up to the tier limit and ignoring fails, so one job will not affect the other. The interesting part here is the attacker chooses to run his mining process on a Windows image, but with WSL bash, which is basically the Windows subsystem for Linux, so that he could run his bash scripts and ELF binaries, which at first glance, it looked a bit weird, right? As he can just run his workload on a Linux image. But the actual intent of this actor is to create another sandboxing layer in case there is some auditing of the system activity. You just want to add an evasion layer from malware scanners. Lastly, we can see that attacker store is a miner under a Git.io domain. And this is another evasion layer that attackers add in order to keep his mining activity under the radar in case of network auditing. But you can argue, what are the actual risks when attacker abuse my CI/CD as a mining farm, right? It doesn't really steal or wipe my stack, right? So there are 3 major risks here. First is the financial loss. Either you run on a SaaS platform or a self-hosted, you pay for the compute power. It could be a runtime token in case of SaaS or a monthly rent for a self-hosted. The second risk here is denial of service. All the runners are busy with crypto mining, right? And as you saw, miner drain your compute power up to the limit. And this definitely would lead to denial of service of your software development lifecycle. And the third one is the most important in terms of risk. And once the attacker has foothold in your CI/CD, he can leak your code or even worse, steal your secret that could lead to compromise of your entire cloud environment. Here's an open source catalog of every known supply chain compromises. So we can really see here that supply chain attacks are just evolving and starting to happen really often. So what we can do. So as you see, there are multiple areas and risks when we look on the software supply chain landscape. So one can try to audit and mitigate a specific risk, like scanning your Artifactory images or scanning your dependencies for vulnerabilities in your source code, or even try to restrict your user permissions, which is extremely important. But as you saw, the blanket is too short in this case. It will not provide a really end-to-end visibility of your security posture. There are too many multiple areas with multiple risks. And as you know, an attacker just need to find the weak link of the change to enter your software supply chain. So again, what we could do about it? So this is why we're partnering right now with CIS to create a new benchmark that looks on every risk from code to deploy. And about CIS is actually a global community of cybersecurity experts which developed benchmark for more than 100 configuration guidelines across different vendors, and those are greatly adopted by organizations as part of the IT auditing process. So we actually took Argon deep knowledge in software supply chain risk and experience and partnered with the CIS community to create a new benchmark. So this benchmark have more than 100 guidance and best practices, and are split into different control and sub-control, which provide practical, down-to-earth guidance on every single risk that allows you to tackle down every risk and separate, but also provide you overall security posture of your software supply chain. So the actual CIS benchmark is going to be released in 2 weeks, first as a white paper. So I invite you all to look and provide your feedback and contribution. But in meantime, we can have a peek of it in Aqua AVD, which is stands for Aqua Vulnerability Database. It contains vulnerabilities, misconfiguration, and also compliance. So let's have a look. So can you see my screen, right? All right, so this is totally free and open source, and it's always keeping up to date. We can find here database of the latest vulnerabilities, right? This is just one example. We can also find here a cloud IAC misconfiguration of all the known cloud platform. And there are also a compliance category. This is where we add a new CIS for a software supply chain. It's crucial to mention that we finished adding just 20% of the entire control. So you can see here right now only partial list. So here the first version. So we actually have 5 categories: source code, build, dependency, artifacts, and deployments. And every one of them contained a subcontrol. So quickly review some of those. Source code is all around managing your source code. Contribution access, for example, is where you verify the members' access aspect. This one, for example, ensure all members enforce MFA, multi-factor authentication. Even if it seems basic, we keep seeing it happen all the time. Organization and members are not applying multi-factor authentication, which puts their identities and their organization at risk. Another one is strict minimal base permission, as happened with Mercedes case that allows free sign up for the GitLab server with permissive base permission, which end up with source code leakage. Let's jump for another category. Build one. So here we have 2 different subcontrol: build instruction and pipeline integrity. So let's see pipeline instruction, for example. This one makes sure you are automatically scanning your pipelines for vulnerabilities. And this one ensures that you put in place sensitive data scanners. So, for example, secrets. This one will make sure no plain text secrets will get into your source code. And another subcontrol is pipeline integrity, which is a very hot topic these days. We have here, which is just a partial list, lock the dependencies, which is very crucial to prevent the future risk of attacker that compromise the dependencies and inject malicious code, or even put you at risk with vulnerable version, as happened with spellcheck. SBOM stands for software bill of material, which is a very popular topic these days. And it basically means that generating SBOM will make sure to sign the artifacts when they were made and how they were made. This will allow you to verify down the road before the deployment that it didn't change since then, and we are proof that all the ingredients are verified. Last control that I will show you is around the Artifactory, which basically focused on the uploaded assets from your build system. Package registry, we will cover here. For example, this one control is also responsible to make sure that private artifacts are not open to anonymous access. The risk is pretty obvious. Eylam shows with CodeGov case that private Docker image that was publicly accessed revealed the secret in the Docker history. It wouldn't happen if the assets wasn't allowed anonymous access. Okay, so we saw a few examples for those controls and checks. Let's get back to the deck. Okay, do you see it full screen? Because I don't. Okay, so now what? So we said that the scope of this quiz is pretty wide, and there is more than 100 guidance to assess on different control. So is it make sense to let the organization validate those checks by their own? Is it going to be yet another long list of supply chain guideline? So at Argonne, we love to ask, how can we help ease the pain? So I'm happy to share that we are working these days on a new open source project called Chainbench. Chainbench will automate those checks and provide the first open source free-to-use CLI that scans your entire software supply chain stack and can show you end-to-end visibility to your risk pretty fast. So before explaining further about Chainbench, let's start with the demo. Just a second, I will share my another browser, just a second. Okay, I got it. Okay, so here we have a dummy repo that was forked from Node Redis, which is Redis client implementation for Node.js, just as an example. As you can see, this is public repo, but you can also try Chainbench on your private repo as well. We have here 23 members, and we also have here a few pipeline under the workflow. Let's just see one of them. So we have here pipeline dependencies and a few steps. Right. So let's run the tool on this dummy repo and see which risks are hidden inside. All right. So before running Chainbench, we need to provide a repository URL and the access token for retrieving the required info. If your repo is public, some of those info is already available for everyone, right? So let's run it. So now we are retrieving the required information. It will take a few seconds. Meantime, you can enjoy those nice emojis. So the output is table format. Each row is a single check. The ID column is correlated with the CIS identifications. And we also have here the title, result, and the reasons with additional information. So right now we have 36 checks that we have implemented recently. And we could also use the JSON format of it with more information such as description, remediation, and a link to the AVD that I presented earlier. All right. So let's say we want to start reviewing those results and mitigate it one by one, right? So let's have a closer look on a few of them, and let me clean the mess a little bit. All right, so right now I'm running the same command just with filtering arguments that make sure I will see just a few of those checks. So on this check, we can see there are 22 inactive users. That means 22 accounts that doesn't need to have access to this repository since they didn't make any change or contribution in the last 3 months. This one tells us there are no enforcement for MFA. So in case of token leakage or even account takeover, which is way too easy without MFA, the attacker will have a foot at your software supply chain, where it could leak your source code, leverage secrets that you might store in your source code. which is exactly what these checks looks for. It makes sure you're running the secret scanner. We also have this one that complains that the base permission is too permissive, so every user has access to create new repo, change code, and run pipeline, which is what happens with the Mercedes case, which allows the attacker to register a new user in the GitLab server and basically dump all the private source code with just the base permission. And what about dependencies risk, right? How do we protect against rogue dependencies like Eylam shows, or even vulnerable packages? So we have these checks that make sure you run a vulnerability scanner in your pipeline. So no vulnerabilities packages gets in. All right, so let's see how we can fix some of those. So let's get back to the repository. First of all, let's apply multi-factor authentication for all the members under this organization. Okay, so we are done. And let's change the base permission from write to read. All right, we're good with that. And let's add a new pipeline that scans for vulnerability packages. So we get into the workflow, create new file, and add this content that I added here. Just a second. Give him a file name. So basically, what's this declaration means that on every push and pull request, we will run the vulnerability scanner trivia, which is open source. So let's get this inside the master. All right. So actually, push code to master is quite dangerous, right? Without reviewers. This is dangerous both for breaking stuff and also as a security issue. So let's add some branch protection settings on the main branch, which is master. So here I required approve of the pull request with at least 2 members. All right, so this will make sure every new change will be verified by additional eyes. All right, so I think we can run the tool again. Okay, so as you see right away, our situation is much better. I would actually go and fix the rest of the risk if I had enough time, but let's move on back to the deck, I guess. All right. So I think with such an automation tool, you can get a big picture without bothering on a specific risk area. You can start thinking of how you could take this to a new capability and leverage it even greater. So a bit more technical details about Chainbench. So Chainbench is written in Go, which allows running in performance while creating just one static binary that can support multiple environments. The tool is built in such a way that it's easy to have new support for new SCM, CI, or Artifactory, you name it. Every new integration has a defined set of instructions that it needs to implement before integrated. So the checks are agnostic to providers. That means one single checks for all providers. And the actual checks were written in Rego by Open Policy Agent, which is policy language that is easy to read and write, especially for non-developers. We currently support GitHub as SCM with 40 of the checks coverage and counting. The checks information list is automatically reflecting AVD, as you saw, once the checks are added into Chainbench. with nightly jobs mean no hassle to make it updated, just one place to manage. So what next? So finally, we plan to release Chainbench as open source project in the next 2 weeks. So please follow us to stay tuned. I invite you all to play with it, assess your software supply chain stack, make it more security. Please provide feedback and contribution. This is crucial for this project and to our community. And by the way, Eylam and I can discuss further and show you an on-site demo at the Austin Open Source Summit. So let's wrap up, I guess.
Great. So with the few minutes that we have, let's wrap up real quick. This was extremely exciting to see. There's nothing like the feeling of seeing that red warning becomes a green pest check. And this is, I guess, this is the power of Chainbench. This is what we're trying to contribute to the community. The idea that securing your software supply chain really doesn't have to be a hassle. So if you click one more slide, and we'll wrap up. So closing with the way we started. The software supply chain, even though we often refer to it as a single process, it's actually composed of a few different layers. We can see them here. So 5 layers from your source code throughout until deployment time. And it's equally important to secure each and every phase, because a failure to do so, as we can see, you can click the slide, a failure to secure your dependencies, for example, your materials, could result in an incident like the one we discussed about code call. And a failure to secure your build pipeline, your build environment, is essentially the case of what happened with the SolarWinds attack. And again, a failure to secure your artifacts, your package managers, could easily lead you down the path of being part of a dependency confusion attack. So securing those chains in the link is important to secure the entire process itself. We can see here the framework, which everything starting from Chainbench to other solutions is built around. So commit to deploy with the different phases. And you can see 1 through 8 is the set of controls that are required to put in place in order to fully secure the supply chain. Now, this is what Chainbench is based on. So Chainbench itself kind of takes away the trouble of getting to know each and every phase of the process, and essentially makes it doable to protect your software supply chain, with much more ease and automation. And hopefully, if you can click one more, then it would prevent you from being anywhere near one of the next software supply chain attacks. And I think that's it for today, right? That's the one last slide. So thank you everybody for the time. I guess we'll be taking some questions with the time that we have now.
Yes, thank you, Eylam and more. Also, congratulations on releasing the new tool and that tool to benefit open source community. Now we're very lucky at OWASP to because you chose us to release this to the world. So there's already a lot of interest in Chainbench. So the question that's popular is Chainbench available already, and how can I get it?
Yeah, Mo, you can take this one.
Okay, yeah, sure. So Chainbench is currently still in progress, and we are aiming to release it in the next 2 weeks. So we are officially going to release it in 2 weeks at Open Source Summit at Austin.
Yeah, so June 20th. I think it's like the first day or right up before the first day of the Open Source Summit, which seems like a proper place to do it. So in 2 weeks' time is the official launch date. You can definitely follow, and once the GitHub repository will be open to public, then start it and join the community of it.
Very well, nice. So just, I think a couple more questions that I was wondering around Chainbench itself, right? And there's also the OpenSSF project scorecard. How does that compare to Chainbench?
Okay, so I will take that. So first, it's worth to mention the scorecard is an amazing project led by Open Source Security Foundation that has more than just one cool project. I do see similarity between both of them. After all, they are both in the same area. The main difference between them is that while scorecard aim to protect open source project, which means it focused on GitHub and on the left side of the software supply chain, for example, code and build. Chainbench is aimed to protect every project, either it's commercial or open source, from the code to deploy. And in addition, Chainbench content is led by a CIS benchmark.
Thank you, Mor. Yeah. And Eylam, maybe you can help us understand CIS benchmark. There's other things like NIST. How are they related or different?
Yes, definitely. So there are a lot of different frameworks by a lot of organizations. So for example, NIST, CIS that we've talked about. So there are similarities, and a lot of the time the organization even work together, so referencing one another. So that's nice. That's like the power of the community. The agenda of everybody is to help secure the process. However, every organization has their own angle. So CIS, for example, is much more specific with the instructions. So it's literally a checks of do's and don'ts on how to secure your software supply chain. What we liked in CIS is that once we read the instruction as an engineer, I can follow it. And this is why Chainbench was built around the compliance framework with CIS. So that's it. The specificality of the checks themselves is what differentiates it from the other frameworks.
Oh, thank you. Yeah, and also congratulations on contributing to CIS body of knowledge. Okay, let's move on to one more audience question. This is from Jose. How do you provide evidence that your actions are effective? That's the first part. And the second part is how to automatically track progress as soon as compliance department requires that.
Okay, maybe I can take this one. So I hope I understand the question as it was put. So the framework itself, what it does, that Chainbench as a project, what it does is help you be compliant with the framework. The framework is CIS Software Supply Chain Security Benchmark. This is the frameworks to be compliant with. What we do is we run through the checks and we help you kind of automatically see if you are good or not so good across the software supply chain. So from left to right, a bunch of checks spread across the process. If you get the red indication, then you are possibly in a risk of a software supply chain attack. And then, as Mo showed earlier, you get the explanation, the specific link to AVD to see more information, and even recommendations on how to remediate the process. If you do a good job and you fix some of those red checks that fail, then they would turn green. And then you would know that you are more secure. One check is a little more secure, other checks could be a lot more secure. Some of them are more weighted than others. And then you would have the challenge of running it, as the question put it, running it like periodically to know that I continue to be compliant with the framework. So that's definitely something that we recommend doing. So Chainbench is scoped to a single repository. So you use it on your GitHub organization and a repository of your choice. And you can do it multiple times. So you can run it again and again. You can do some automation around it, like scheduled checks to know that you're always compliant with. Or you can use off-the-shelf product. Obviously, a lot of the work that we do here in Aqua is automating Chainbench to give it to you just kind of as a turnkey solution.
Thank you, Eylam. All right. I think we have answered the audience questions. Yep. I think overall, this was very good. We saw multiple demos and the great contributions that your team is making to open source and helping us reduce our security risks. Thank you, Eylam and Mor, and good luck with the next conference and the launch of CodeBench.
Thanks for having us.
Thank you very much.
Yes.